Some people say statisticians are sadistic, but I say they're just a bunch of standard deviants. You get it? Standard deviation, deviant. Anyways, let's get to weighted averages. Now, these are frequently used to determine overall grades. If you're actually trying to figure out your grade in this class, there are different weights for things like tests and for daily work. And that is because of different levels of importance. Now, it can also be used to determine averages from frequency tables when we use the frequencies as the weights. So first of all, we're going to do some standard weighted average problems. First of all, you're going to multiply each value by its weight. Weights could be, like I teach at a summer program, and daily work has a weight of 1. The test during the program has a weight of 2, and the final exam or project grade has a weight of 1. So I have to take each of these groups and multiply them by their weights. Now, the other way you could do it is in normal classes, like my AP Stats. I believe the weight for test is 50%. For quizzes is 35%, and daily work is 15%. And what you would do there is you can multiply each of those by decimals or by, like 50, 35, and then 15, and it would still all work out. Then we're going to take all our products, which we got from the previous steps, where we took the values and multiplied by the weight, and divide by the total of the weights. Now, the cool thing is if you're doing percents and you do it in decimal form, the total of the weights is going to be 1. So there's really not this extra step that you need to do, although it's good to show. So in this example, I have my AP Statistics course with the weights for the different categories, which I just discussed. And Simon has the following scores in each category. He has 87 for test, 80 for quizzes, and 95 for daily work. What is Simon's current average in AP Stats? Well, to take the mean, I'm going to multiply. Where do I get the 0.5 from? That's 50%. And there's the 87 that he has for the test, 35% weight for quizzes, and a 15% weight for his daily work. And multiply all these out, and I'm going to divide by the sum of the weights. Now, since I did percentages as decimal, my weights add up to 1. So it's really just adding up the numerator here, and I get 85.75. Could I have used 50, 35, and 15 instead of the decimal form? Yes, as long as I used 50, 35, and 15 on bottom, which would have given me a divisor of 100, and that still would have worked out and given you the same answer. Now, I've also created a little paper on ClassPad.net, but you can create your own. It's pretty simple, and I do have a video up on my website that shows you how to use it. First of all, you're going to enter the items being averaged in column A, all right? Then you're going to enter the weight, or sometimes frequencies, which we'll talk about later, in column B. Highlight both columns, and then you're going to select calculation, which is in the statistics tab right there. And then you're going to select one variable, which is what pops up after you hit calculation. Then you can click on more for full results. Now, you'll see here's the average right here. It's 85.75. And since my weights were decimals, it added up to 1. That's also my sum of x. Now, the interesting part, if you look at the data here, you see that I have a standard deviation for population, but not one for a sample. Why is that? Well, since the weights add up to 1, that's like the weights adding up to 100%, which means I must have all the population data. I don't really have a sample. I have a population. And the calculators and the spreadsheets seem to know that, and they just give me that. Let's go ahead and look at another example. This one is an engineering summer program like the one I teach at Houston-Tillotson. The midterm has a weight of 2, daily work has a weight of 1, and the final has a weight of 1. Now, I have to give a report in the middle of the program on Alana's grade. And so far, her midterm grade is 94, and she has a daily work grade of 100, all right? So what's her average before taking the final? Well, if I added in the weight for the final, that's not really fair because that's almost like giving her a 0 on the final right off. So we're actually going to ignore this weight of the final, and it will come into play later when she takes the final. I'm going to put that weight back in. So it's just these two weights that come into play. The 2 times the midterm grade plus 1 times the daily grade divided by the total weights. So she has an average for her report of a 96. At the end of the school year, we like to have a pizza social for our math club. So I'll send out a survey and say, how many slices of pizza should I order for you? And I'll get answers from 0, don't get me any, that's fine. Usually most of the kids want a slice of pizza, and I get answers as high as 8 slices. So now my job is to figure out how many pizzas do I need to order. And if I can figure out the total number of slices I need, then I can go from that. All right. So here's some survey data I have from one time and the number of slices. And if I just added up 1 through 5, I'd get 15. And I know, let's see, I have 4 kids that want 1, 8 kids that want 2. That's 16. So that doesn't make sense. That is not how I'm going to figure out my total slices of pizza. This frequency thing here is telling me I have 4 students that want 1 slice. Now, if I had had a list of data instead of a frequency table, I would list 1 4 times, all right? Then I'd have to go list 2 8 times. And it's much easier instead just to do the table. So how do I work with that? Well, I know if I want the total slices, I'm going to take this 4 times that 1. And by the way, let me see, how many total students did I pull? I pulled 33. Now I have 4 as a total here for the frequency times the number of slices, and 16 here for the second row. I have 36, which are 12 students that want 3, 6 students that want 4, and 3 students that want 5. So the total number of slices that I need to order are these 4 slices, those 16, 36, 24, and 15, or basically 95 slices. Now, if I wanted to know the average number of slices eaten by students, I would just say, oh, take this total 95 and divide it by the total number of students, 33, and that gives me 2.88, which means I can now actually go calculate my deviations. My deviations, remember, are x minus the average or the mean. 1 minus 2.88 is negative 1.88. 2 minus 2.88 is minus 0.88. Now, the interesting thing is, well, let me go ahead and do my squared deviation. So that's our next step in finding standard deviation and variance, is squaring the deviations, all right? And I get 3.53 and 0.77 when I square both these numbers. And you can see I show the work for some of the other numbers down here in the rest of the table. Okay. Now, the interesting part is this isn't necessarily going to add up to 0. Why is that? Well, this is one deviation for the one student who ordered 1 slice of pizza. This is deviation, the negative 0.88 is the deviation for one student who ordered 2 slices of pizza. Because these are lacking the frequencies, I'm not getting the 0. But if I actually multiplied this by 4, this by 8, this by 12, this by 6, and that by 3, and added them up, I would actually get 0. So that's how I'm going to fix my sum of my squares, because if I add them up here, I'm going to have the same problem. This number is going to be too small because this is the deviation for only one student, the squared deviation for only one student who ordered 1 slice. This is the squared deviation for only one student who ordered 2 slices. But how many of these do we have? Well, we have 4 of these, and we have 8 of these. So I go ahead and multiply it there. Now, because I taken the frequencies into effect, I can actually add everything up. And this will give me my sum of my squared deviations, which means now I can calculate my variance. Remember, variance is the total sum of squared deviations divided by the sample size minus 1. So it's going to be 41.52 over 33 minus 1. So don't forget that minus 1. And my answer for variance here is 1.30. And my standard deviation is just the square root of that, 1.14. So some of you will occasionally say, how do I find you'll use a class pad or something, which I'll show in a sec. And you're like, how do I find the variance I have the standard deviation. Well, you can just go backwards on that one. Okay, just like we did in the previous lesson. Now, if you're dealing with classes, the problem is here I was looking at ages of people who were playing Pokemon, and I did 10 to almost 20. Remember, the bar here means the 10 is included, and it stops just before 20. How do I find statistics for that? Do I use the 10 or do I use the 20? Well, I really should compromise. And so we're going to use something called a midpoint, which is, in this case, would be 15. So filling out the table, let's go ahead and finish our class limits first. There they are. All right. 10 to almost 20, 20 to almost 30, 30 to almost 40, 40 to almost 50, 50 to almost 60. And I do run into people older than that playing Pokemon. By the way, I play Pokemon. All right. So let's go ahead and find the midpoints for each of these bars on our histogram. Well, in this case, it'll be 20. Well, there's my total frequencies. Almost forgot. This case, it's 25, 35, 45, and 55. Just like before, this is like my new x. All right. So I'm going to multiply my frequency times my midpoint to fill out my f times x column. And then I can add all those up and divide by this total here to get the average. Remember, we don't have to do n minus 1 on averaging. That's a special variance thing, not an average thing. So I get 31.4 as the average age of this group. Then I want to calculate deviation. So I'm going to do 25 minus 31.4. And 35 minus 31.4, that's about 3.6. Or 3, yeah, it's roughly. And then I will square these just like I did before, and then multiply them times their frequencies. Then again, we're going to go ahead and add up this whole column to get the sum of the squared deviations. Remember, that's not the variance. That's just the sum of the squared deviations. It's almost the variance. All I have to do is divide this by 64 minus 1. So I get a variance of 261.5, take the square root of that, and I have my standard deviation. Now, sometimes you'll be asked to find a median on for a histogram or frequency table. How do we do that? Well, in this case, because we have the bars here, first of all, this will work if I have single values or ranges of values like I do here. All right. First, total the frequencies, all right, and divide by 2. Count through the frequencies till you get halfway through. So here I get 2 groups of 32, right? So my median isn't really 0.32 or 0.33. It's halfway between them, right? So if I'm counting through, this has points 1 through 24 if I put them in order. And then this is going to have points 25 to 36. Well, I know both the 32nd and the 33rd point are in here. And I don't know where exactly it is, so we'll just use the midpoint and say the median is around 25. Now, I have also created a ClassPad paper, and there's a video on my website on how to use it. Here's the source of the paper. Again, use the midpoints as the x values and the frequencies as the weights, and you can use that to calculate a lot of your statistics and skip the table section. But you're still expected to be able to fill out a table individually to know how each of the steps work.